Welcome to this, in the first of a two-part bit on compound functions. Compound functions are where we're putting functions within functions and so on. And it may seem quite complicated at first. So I've broken it into two stages. One, a very simple example, and the next, the sort of thing you might have come across in the classroom. This video is based on materials created by Professor Mark Cavazza of the University of Greenwich. And is presented by me, Andy Wicks. So let's do a little bit of theory first. First of all, tactics matter. It matters how you go about doing things. If you're writing in some languages, you can write a fair bit of code before you have to go back and check. But in functional programming, slowly really does equal faster. The slower you go, the faster you'll get to the end. Some people will say, oh yeah, but I'll just do. Don't. You'll see, you'll make that mistake and then you'll come back and have to do it again. What you do is you do a little bit at a time and get that working. You make sure it works and then you add a little bit more and check that that works. And you go through, you keep adding a little bit at a time, and you do not try to save time by doing two or more steps at once. One step at a time, and that's the quick way of going about things. So let's have a look at a particular problem. This simple problem converts centigrade to Fahrenheit. There's a formula for that, 9c divided by 5 plus 32. So if we wanted to write a program that did this in Scheme, how would we go about it? Well, what we wouldn't try and do is convert 9c divided by 5 plus 32 into a Scheme formula straight away. That way lies madness. What we do is we do it a step at a time. You make an assumption, so let's say 20 degrees centigrade in Fahrenheit, and then you work out by hand what you'd expect that to give, and then you work through slowly one step at a time. Let me show you. The first bit you do is 9 times c. Well, 9 times c is just 9 times 20 in our example, and that gives 180. So we check that whatever we've entered into Scheme gives us the answer 180. Then, having done that, we can divide that answer by 5. So we get 180 divided by 5, and that gives 36. Having got that correct and working, well, what would we expect the next stage to be? What happens when we add 32? Well, we know that 9c divided by 5 is 36, so it's 36 plus 32, which gives me 68 degrees Fahrenheit. Now that's the theory. Let's see it working in practice. Let's nip into Scheme. The first thing we have to do is to create our basic function. So what we need is a function called C to F, convert centigrade to Fahrenheit, and we're going to take a value C, a particular value of centigrade, and then that function has to do something. So that's what's in the second set of brackets. As you know, we use Polish notation. So what we're doing comes first, the multiply, then space 9 space C. That's the first part that we decided we were going to do in the PowerPoint presentation. And if we have this function and we run that with 20 degrees centigrade, well, what do we get? If we do that, we get 180, which is what we were expecting from our manual version of the formula. So let's make that formula a little more complicated. Since we know that times 9c is now correct and that our function works, we can then go about doing the divide by 5. So what we want is another opening bracket and divide, because it's Polish notation. The task that we're trying to do comes first. And what we want is that star 9c to be divided by 5. In other words, we set it up in exactly the way that we would say it. But how do we know where the brackets go? Well, we need an extra bracket because we've got an opening bracket that's been added. So where do we put that other closing bracket? Well, if we click just after a bracket, we can see what that bracket covers. We don't want that closing bracket to be there because that would exclude the 5. So if we put the other bracket here, well, that wraps that piece of the code up. And if we click at the end, we can see that, yes, we've closed this function. We've got all the brackets in the right place. Let's try running that. And what we get is 36. That's what we'd expect. So now we can move on to the final exciting step. Here we know that we've divided 9c by 5 correctly. The last part is to add the 32. So we need another opening bracket plus 32, and then we need another closing bracket. So where do we put that? Well, we use the same trick again. If we click just after a bracket, we see what it covers. That's the 9c bit. If we click after the next bracket, we get 9c divided by 5. So the new bracket needs to go after that. That has to be this bracket. And yes, now the working part of this function is covered. And just to check, we'll make sure that the last bracket does cover the whole function. It does. So let's see whether we get 68. And we do! Excellent! What we've done is written a function that takes a function that takes another function and gives us the answer that we want. We've got a compound function, something that looked as if it ought to be complicated, but because we did it one step at a time, getting to the end was easy, whereas getting to the answer that you see up the top here without that would have been a lot more difficult. Coming up with that in the first place is not trivial. So you build it up one step at a time. But there's another little bit that I've got to tell you about. You always have to check your answers. Yes, we expected to get 68, and yes, we got 68, but was what we did originally correct? Is that correct? Is 20 degrees centigrade 68 degrees Fahrenheit? How would we check that? Well, the easy way is a simple check on the internet, and that will actually show that this is correct. 20 degrees centigrade is 68 degrees Fahrenheit. But what about converting Fahrenheit to centigrade? How hard can that be? Well, here's the formula. Why don't you have a go at creating that in Scheme?